Section 8.2, we will introduce Lewis structures. These are ways of drawing covalent molecules so that you can see how the different atoms are bound together to fulfill still the octet rule. None of the compounds we will talk about won't qualify to do that. All right, so Gilbert Lewis was the one who came up with these. He was a chemist at Berkeley during the late 1800s, early 1900s, and he discovered the covalent bond. So he was the one who came up with the covalent bond. And he created a way to draw covalent compounds. And this is widely used still today. So if you take if you take organic chemistry going forward, you will definitely be doing this. He was nominated, interestingly, 41 times for the Nobel Prize in Chemistry and never won, poor guy. But he's very famous now, and lots of students know his work. All right, the Lewis structure represents a molecule with the bonds between the atoms represented as a line. All right, so here's some examples on the right. So we have ammonia, which is NH3, hydrogen fluoride, and a carbon tetrachloride. So the bonds in these molecules are represented by a line. Each line represents a pair of electrons, so that equals 2 electrons. All right, but atoms still follow the octet rule, which means that they want 8 electrons in the outer shell. All right, so that will help us determine how the atoms bond together. So let's do an example here. Ammonia. So the molecular formula for ammonia is NH3. So there's 1 nitrogen and 3 hydrogens. Right? If we draw the electron dot structure for all of these, you remember each hydrogen is going to have 1, and there's 3 of them, so I'm going to draw 3. It's going to have 1 electron. The nitrogen, if we look in the what row it's in, it has 5 valence electrons. So we can draw 2 here. I'm going to draw 1 on each side. So what happens is that these 2 guys will get together and share an electron to help fulfill the octet rule. So nitrogen wants 8 electrons around it. Hydrogen only wants 2 because of its electron configuration. If you can remember, hydrogen has a 1s1, so it only needs 1 more electron to fill its outer shell, and then it's pretty happy. So what happens is the nitrogen will be here, and on each side, a hydrogen will come and share its electron. So 3 hydrogen will bond with the nitrogen, and then it will have 1 extra pair. Now this is called an unshared, you should write this down, an unshared pair, okay, of electrons. And it will have 3 bonds. So nitrogen then looks like it has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. It fills the octet rule, and it's happy. Each hydrogen looks and sees that it has 2 electrons around it. So to draw the Lewis structure, what we do is we take each bond and draw it as a line. So that would be hydrogen bonded to nitrogen 3 times with our extra pair of electrons still. So those are not bound. Those are just part of the nitrogen atom itself, okay? And that is the Lewis structure for ammonia. And let's do... so to do the covalent bonds, we're going to need to know how many valence electrons they have. So just to remind you, there's 1 here. There's 2 here, but we're not going to be really using them. 3, 4, 5, 6, 7, and 8. Okay? And we're just going to be using the nonmetals. So we're going to be going basically from carbon on over. So how many valence electrons do we have in each of these compounds? Okay, so this one has 2 fluorine, all right? So each fluorine has, if we go back here, fluorine has 7 valence electrons. So we have 7 plus 7, so we have 14 valence electrons here. Carbon dioxide, so carbon has 4, all right? This each has 4. Each one of our oxygen has 6. And we have 2 of them. So 4 plus 6 plus 6, we have 12 plus 4, we have 16 valence electrons. Remember, our carbon has 4, hydrogen has 1, oxygen has 6. So we have 1 carbon plus 2 hydrogen plus an oxygen. So this one will have 12 valence electrons. And lastly, this is hydrogen peroxide, H2O2. Hydrogen has 1, oxygen has 6. So 1 plus 6 plus 6. This one will have 14 valence electrons. We need to know the valence electrons when we draw our Lewis structures. It helps. There's a little bit of accounting you have to do with the electrons. All right. So what are these steps or rules for drawing a Lewis structure? So our example right here is hydrogen chloride. So first we want to determine the number of valence electrons. So for HCl, we have 1 plus there's 7. So we have a total of 8 valence electrons here, all right? Now we want to draw the two atoms together. So we'll draw our hydrogen and we'll draw our chlorine. Now, since there's just 2, we can draw them side to side. If we were drawing more than 1, we would put the least electronegative in the middle, or hydrogen. Hydrogen always goes on the outside. Then we put lines between the elements to make a chemical bond. So there we make our line. We complete the octet on the outside element. So hydrogen only wants 2, and it sees 2 electrons here, so it's good. So we have 8 electrons. There's 2 here, so we have 6 to put around our chlorine. All right. And then we make sure everything fulfills the octet rule. So hydrogen sees 2 here, chlorine sees 2, 4, 6, 8, and it is happy. So we are now done. All right, so let's do another example. So the number of valence electrons, so hydrogen has 1, so 1, there's 2 of them though, and then oxygen has 6, so we're going to have 6, 7, 8 valence electrons. All right, we're going to draw the oxygen in the middle and the hydrogen on each side. Now, it doesn't really matter where you put the hydrogen. All right, each bond has 2 electrons, so that's 2, 4, so we have 4 more electrons to put around. Now, we don't want to put them around the hydrogen because hydrogen will never have electrons around it. So we can put the electrons around the oxygen, okay? All right. And that's that one. Okay, so let's also talk about diatomic elements. So diatomic elements is a molecule composed of only 2 atoms, so like F2 or H2. So we look at F2, the number of valence electrons is going to be 7 plus 7. Since there's 2 of them, it's 14. All right, we are going to draw the Lewis structure with a bond between them. We have 12 electrons to put around, and we can put 2 on each side. All right, so if we look, we can now draw all of it. So now we have 14. So 2, 4, 6, 8, 10, 12, 14 electrons. And we are done. Now, if we look at H2, we only have 1 plus 1 valence electrons. We have 2. All right, so if we draw hydrogen, this is the simplest one. Just has a bond between them. We have the 2 electrons in the bond, and we are done. All right, single bond. So this is a bond where just 2 electrons are shared. So let's do the example of CH4. All right, so carbon has 4 valence electrons. Each hydrogen has 1. All right, so we add all those together. We end up getting 8 valence electrons. Now to draw this, we want to draw, the hydrogen is always going to go on the outside. Carbon is going to stay in the middle. We can draw 4 bonds on carbon, 1 on each side, and we can put the hydrogen around like this. So hydrogen will always be on the outside, along with any other elements from group 17, and they will all make single bonds, all right? So they will make 1 single bond, hydrogen and all elements in group 17. And if we look, we have 2, 4, 6, 8 electrons in our Lewis structure, 8 valence electrons, and we are good. All right, so now it's your turn to practice drawing some Lewis structures. So remember, these are all single bonded Lewis structures. So try them and see how it goes. We will review.